Hey everyone, Morgan here. So we're on page 7 of the Thermodynamics lecture outline for AP Chemistry, and we're going to be applying a lot of the ideas developed on page 5 and 6 previously about free energy and the spontaneity of reactions. There are 3 things that we have to consider when talking about spontaneity: enthalpy, entropy, and temperature. And when you put those 3 things together, you get what is called the free energy, or Gibbs free energy. Now, I've got some questions here, not involving any numbers, okay? Just positives and negatives, okay? So, the phase change, H2O liquid to H2O gas. That is water boiling, okay? Does water spontaneously boil at room temperature? The answer is no. This is non-spontaneous, and delta G is a positive. Now, anytime that water boils, goes from the liquid to the gas, you have a massive increase in entropy. Remember, the entropy of a liquid is much, much less than the entropy of a gas. Now, how is it that you make water boil? You heat it. That means endothermic. That means we're putting energy in. Okay, let's look at the reverse reaction, which would be water condensing gas to a liquid. It's at room temperature. Yes, that happens spontaneously. Delta G is negative. For any spontaneous process, delta G is negative. For any non-spontaneous process, delta G is positive. Now, delta S would have to be negative. That's entropy. And when you go from gas to liquid, you become much more orderly. And how can you make something condense? Well, you take the heat out. That's exothermic, or delta H being negative. Now, what does this mean? We have to talk about something called the driving force. What causes the reaction to happen? Now, an entropy change that's positive is favorable. But one that has an enthalpy change that's positive, endothermic, is not favorable for spontaneity. So in this case, the entropy is the driving force, whereas in this case, the enthalpy is the driving force that causes the reaction to happen. Now another phase change here. Again, room temperature, water solid to water liquid. We're talking about an ice cube melting. Ice cubes melt spontaneously at room temperature, so delta G is negative. Now the entropy change would be positive. As you go from the solid to the liquid, there's much more disorder. And how do you melt an ice cube? You put heat in. Delta H is positive. Now I'm going to change this around in terms of the temperature. This is below the freezing point of water. Delta G is now positive because below the freezing point, ice cubes do not spontaneously melt. Now the delta S and the delta H don't change because of a temperature change like that. Okay? What this is designed to point out to you is that there is a big difference with a temperature change in spontaneity. Spontaneity is very much temperature dependent. Okay. Thanks for tuning in. This is Morgan, signing off.